Hey everybody, this is Larry. This is day 21 of the January Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Is my computer going slowly? Maybe I have Xcode up. Alright, let's close this Xcode. But yeah, hope everyone's having a good day. My computer's running a little bit slow. Sometimes I can't tell if it's just Leetcode anymore, honestly. Because this is what I missed about the old Leetcode, if you will, because it was just like basic, but in a good way, because everything just works. Now it's still like loading everything. I think it's loading the color syntax. There you go. And I don't know, like I don't know. Anyway, let's take a look at today's problem. We have 3315 construct a minimum bitwise array 2. Is it the same as yesterday? But obviously part 2. And primes, we have the bitwise or minimize the each value if not possible. Okay, so I mean this is the same problem as yesterday, except for now it's 10 to the 9, which is kind of okay. Because it's 10 to the 9, we cannot do a for loop like we did yesterday, right? But we can probably still, I mean, we probably still have to basically write the same thing we have yesterday, right? Which is for x is equal to nums. Maybe you have like a right, f of x, and then return answer, right? The tricky part, of course, is that now f of x is different. Okay, let's see. How do we want to think about this? Okay, so I mean, I think this is a bitwise number, so we have to kind of think about well, things in binary, right? I'm going to do some ASCII art here. Honestly, I don't know the answer. Even though, I mean, I guess you can say maybe I could have predicted from yesterday or something, which is probably true. I just don't care enough. So maybe it's new enough to me. I don't know. I haven't thought about it. But the way that I think I attack these is just to kind of figure out how to visualize and how to build some sort of a rule set or strategy that we can think about. And of course, the way that I do that is by playing with small numbers. So let's say we have 11, and especially the input numbers, right? The computer is a little bit slow. 11 is what? 8 plus 2 plus 1, right? So that's 1010, is that it? 1, 2, 4, 8, right? So okay. So then now we're trying to find the answer here. We know that this bit has to be a 0. And you know that here it's going to be something and a 1, right? Because it's, well, I guess it doesn't have to be that way. It could be in one of the two ways, right? It could be 1, and then the next number is a 0 or something. And then it could be the other way around, right? Okay. That's not super helpful, honestly. But, okay. So in this case, maybe we can do something like this. Right, because this plus 1 is equal to this. I mean, that's fair, that's fine, right? And that's, what is this? This is 9 and this is 10, right? So then now we have 11. Okay. I mean, we figured out manually, just by guessing, and it seems pretty straightforward. But, you know, now you have to figure out a consistent way to get the thing to tell you, right? Actually, I don't know, to be honest. I think, well, one thing I would say is that it is prime numbers, right? What do prime numbers mean for me? Well, that means that, well, other than 2, everything is an odd number, right? Which, I guess even numbers are impossible anyway. It's impossible for 2, but it's also impossible because you have 0 and 1, always the last digit. So, okay, so we know that this digit will always be 0 and 1 in some way, right? And then the question is whether you start with this or you start with this, right? Meaning that you have this here. I guess without loss of generality, this is not very interesting, right? Because going from here to here, like meaning that you're going from a 0 to 1, it actually doesn't change anything. It just means almost like this number minus 1, right? So that means that if you have 11, maybe this number, right, you can also have 11 minus 1, right? I mean, that's trivially true. It's not always true for every number. Or every prime at least. I don't know if it's every number, but every prime, I guess it's trivially true because it's just, we know that every prime number other than 2, every odd prime, maybe call it that way, every odd prime has the last digit is a 1, right? Which we knew, right? And then it's just converting to 0. That means that, I mean, this is something that I didn't think about. Maybe you did. Is that at the very least, if you give it a number x, where x is an odd prime, it is going to be at worst x minus 1 and x plus 1, right? I forget which one you return, but you know. So, oh yeah, and 13, that means 12. 31 means 30, right? It's not the minimal, but that is a basis, right? Okay. Then the idea is, then how can you do better? I think that's the next question, right? I mean, converting from here to from here to here, right? Or the other way around, from here to here. I mean, obviously you can just try subtracting 1. That's fine, but is that really? Because 31's interesting, but I don't know if it's just lucky that it is a power of 2, right? Because then now you have, well, 31 is something like this, maybe, right? So then now, that's just equal to this. And there are not that many primes like this, right? Because that's literally called a mercenary prime or something. I don't know if I'm saying that right. It's been a while since I know how to spell it, but I don't know how to say it. That's I guess I could have done, you know, mercenary prime, but I don't know how to say it. I don't know why my computer's still slow. Sorry, friends. So it could be a mercenary prime, but pronounce. Okay, that's the part that I want to. Even my Google is slow. I mean, I know how to say prime. Mersenne prime. Mersenne prime. Okay, I don't know if that's right because it's supposed to be French, so I don't know. But in any case, so this is the only case. And you know that there's a limit, right, in how small the number can be because it has to have a 1 here, right? Because it's a bitwise OR. So whatever number that you have, let's say you have, you know, you still need a 1 here. And maybe in this case it's not possible because it's an odd number. But as we said, we can, you know, just do, right? So that means that this is going to be the only case in which, you know, maybe that's it, right? We try. Yeah, because you can only, well, no, I mean, there could be some other stuff, right? Like you could have like do, and then do, right? So then that in this case would be do, right? So then in this case, you cannot just, you know, you cannot just, I don't even know what this number is. I didn't think about it, but I would just kind of come up with examples. So here, you know, you see that it's not like, you know, you can't just do what I was mentioning. But that said, it does emerge a pattern, right? Meaning that, I mean, this is kind of the same thing as a Messalene prime idea on the suffix. And then it just becomes, well, let's take the suffix. I'm also trying to think whether I can think about this recursively. Right. This is so annoying. how do I express this? Huh? What is this number anyway? This is, what's that, 8? So that's 15. 15 plus 32, so that's 47, right? And this is, what's that, 7? 7 plus 32 is 39. I may be wrong, I'm doing this off my head, right? And then this is 8 plus 32, so 40, right? Well, I mean, that's just plus 1. I shouldn't have to do that one. That's just dumb. But okay, right? I mean, my idea would be that, you know, you take some prefix and then you subtract 1 and then see if that works. Because you definitely need the prefix, right? And it also works for the default case because the default is just taking the entire number, which is the prefix of the entire number, right? You're just trying to figure out if there's a case in which, you know, I think that's it, honestly, but it is a hard proof for me to kind of come up with. It's just that this idea that here, well, I mean, I think the idea is that you have to guess one number, or you don't have to, but it's not that you only have to guess one number, it is that one number determines the other, right? And I'm trying to think whether you also need to do a +1 here, because if you want to try, say, here, I guess not, because in that case, that would be your prefix, if that's your number, right? Maybe. Okay, let's give it a spin. Honestly, this is one of those things where, like, you just kind of, for me anyway, a little bit YOLO. My proof is not very strong, but yeah, so you have X. How would I write this anyway? So you want to keep the prefix. Right. Okay, so I guess we could do it backwards. We can have okay. And this is awkward. So what I'm going to do, and this is very awkward, is just have a lot of ones. I'm going to right shift them, so then it shifts them like, you know, this way, and then left shift them back, so then that's where you get the prefix bits, and then with the prefix bits, then we'll just use it as a mask, right? So mask is equal to, let's just say b minus 1, right? Where b is equal to 32. You might have to change it in different languages because of overflows and stuff, but this is what I'm doing with, right? And then now we have for I in range of b, right? So then you have mask I and then I, right? So this gets rid of the last whatever bits. So then now and mask is equal to this. And then X and mask will give us the mask that we need, right? So this is T for target, right? And then if T or T minus 1 is equal to X, then T is a candidate. What are we trying to do? Max or min? I forget. Oh, min, of course. So yeah, then T is equal, best is equal to min, best T maybe, or T minus 1 actually, I think. And then that's it. And then we have to do some maths on the -1. I mean, not maths, but just like test, right? Maybe something like this. Let's give it a spin, right? Looks okay. I mean, I think the logic kind of makes sense. The idea is that because it's an or, and because you're doing a +1, the prefix cannot really change that much for it to have these, right? Because you can't just like mix and match and stuff like this. So that's kind of my idea. I don't know if that's true. All right, YOLO submit. Hopefully this is right enough. Okay. Honestly, I don't really have a great explanation for you here. You saw how I did it. You saw how I walked through it. Just visualization, seeing some sort of a pattern. And a lot of it is going to be intuition, but it's not like intuition like, oh, you're just born with it smarts, right? It's intuition from just like years and years of practice of doing bitwise ORs and kind of feeling things out with like, well, you know, like for example, maybe you can say that, you know, if you have this, the reason is because then now you know that this can never be a 1 because it's bitwise OR, and you have stuff like +1 and stuff like that. So there's like stuff like that you can kind of reason it out, but honestly it's not a proof or anything, right? Definitely not by any mathematical rigor, but you know. But yeah, that is all I have for this one. Let me know what you think. Yeah, and you can definitely write this in a slightly different way, of course. But this is how I thought about it. Let me actually explain this part really quickly. I mean, I didn't even go to complexity, right? This is linear. This is over b, where b is the number of bits. You can say that this is also over b, so maybe you can say it's b squared, and maybe that's true, depending on how you categorize like bit shifts. But the idea here is that I just have a bunch of 1s, and then now the right shifts will cut it off here. And then now when you left shift back, it just now replace them with 0s. It's kind of what happens, right? So if I is 3, that's what happens. And basically that comes with this. You can probably write this in a different way, actually. Maybe this way is a little bit, I don't know. I mean, people, I don't know. It sometimes sounds like people kind of memorize these things, and maybe that's true. But as you can see, I don't actually, I just kind of try to figure out, I look at it like another problem. I try to figure out what I want, and I get it. Another way that you can think about it, of course, is just you have and then you have maybe XOR 1 1 1, right? If you do something like that, I guess that'll be fine, right? That's the same idea, which I guess I could have done. That maybe is a little bit more straightforward. Like you can write something like, how's it go? So mask is a full mask. We want XOR. We want 1 shift by I minus 1, right? And that's it, right? And this should be good, hopefully. Because otherwise, I'm just see same idea, right? But I mean, it's just different implementations, and you can come up with it if you just kind of have a strategy about it and don't be too intimidated by bit masks. But yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.